Okay, in this video, let's talk about logistic regression. In the past set of videos, we have seen linear regression, where if you remember this figure, this line is supposed to be the ideal line which goes through all the data points. And if you look carefully at these data points, these are actually falling on this line. So for this set of data points, this line is ideal, and linear regression works for this case. But what if our data points were arranged in this way and not in the way in which we have seen so far? So if you look carefully here, it looks like these data points are arranged in the form of two lines. One is here and one is here. And these two lines are kind of disconnected, as in this line is completely independent of this line. And this is a typical situation where the y-axis has only two values, or rather the y-axis is binary, in which case we have one number here corresponding to these points, and one number here corresponding to these points. So we have one y value for one set of points and another y value for another set of points. Typically this y value is 0 and typically this y value is 1. So the y values in this case are generally either 0 or 1, and that's why it's called a binary kind of a data pattern. And we'll see how we can use what we have learned so far to make the machine learn this kind of data, or rather we'll see how we would like the machine to fit this data in the best way. Now ideally the machine should come up with this line and this line, and that is something which the machine is not really very good at, because the machine generally likes to come up with just one line. It does not like to come up with two disconnected lines. But if we think about what we can do with this one line in order to fit the data that we have, you can imagine that if we kind of try to change the way this line looks, if we pull this point down and bend this line slightly, and if we pull this point up and bend this part of the line, then it can look something like this kind of a curve. So this point is pulled downwards and this point is pulled upwards. And if we have something like this, then you can imagine that this top part would represent the ones of our data, and this bottom part could represent the zeros of our data. So let's focus on just this part and see how we can visualize this new line into our data. So this was the point in our data where we saw a bunch of positive points, and this at this point, before this point, were all zeros. So if this bent line fits exactly in this way, then maybe we somehow approximate our data expectation, which corresponds to the positive, or in this case ones and zeros. So to help you imagine better, I have drawn this line here. So this part of this curved line is somehow closer to the actual data points on this positive value of y, and all the points on this bent line before this value of x corresponds to somehow these data points which have y equal to 0. So this is a very rough approximation, but this is the only way the machine can predict these points, or rather this is the only solution that the machine can come up with for representing our data, which is only on these points or on these points. And you have to remember that this is actually supposed to be a straight line which we have bent. So the machine is actually going to come up with a straight line, and we are just going to bend that straight line to somehow help us in our situation. So just to remind you, this is the line that the machine is actually going to come up with. So after all, if this is the line that the machine has to come up with, then we have to for a moment forget about the bent line and just focus on how the machine could come up with this line. And for the machine to come up with this line, the machine has to come up with nothing but the ratio of this height by this width, which is W, and this distance, which is B. So if the machine is able to come up with these two values, then we can somehow manage to fit this line in our weird looking data. So in the next video, we'll see how the machine can come up with this line such that this is appropriate for our data.